Hi, everybody. So for this one, we're going to talk about scale. And it's what our first lesson in math is going to be about this year. It's a concept that I think you probably are a little bit familiar with, whether or not you actually know the word scale that's with it, because we use scale drawings or scale models a lot in the world. For example, on the screen right now, you can see an example of a scale drawing, which is a map of the zoo. So it would be really hard for you to fit the whole zoo in your hands because it's a big thing in the real world. But it's helpful to be able to have the whole zoo in your hands as a map so you know where everything is and you know how far things are from each other. So if it's getting near the end of the day and you're getting tired or it's almost going to close or you almost have to go home, then you kind of know what you still have time for. So when we make this, what's important or why this becomes connected to math is that there's a really specific way that we want to make it so that it really represents what the real world is like. So when we have a scale drawing here, we could have things that get bigger or get smaller. So for example, this one got smaller because the zoo in real life is really big and this is small, so you could fit it in your hand. But I could also make things bigger and try to think about scale. When we do that, we need to have, like I said, a specific math way to take care of it. Because, for example, with this picture, if I wanted to make it bigger, I could if I drag it right here. My picture is definitely bigger, but it doesn't have the whole scale thing working for it or going on because if you look at it, it doesn't look like the original picture. All our faces look really stretched out. So if I undo this, hopefully that if I want to make this bigger, I actually have to drag this corner down here to make it get bigger so that now I have a bigger picture, but everything looks right because when you're dragging that corner, you're really making it bigger with both of the dimensions or both of the sides there. And that's what we're going to end up doing when we do our scale problems, is making sure that if we make something bigger or smaller, we're making it bigger or smaller in the right way so that the new one will come out still like the original, just bigger or smaller. So in your notebook, we're just going to fill in some of the vocabulary that's connected to scale. So if you didn't have your notebook up already, you can pause right now and grab and get open to this page. So starting off, a scale is something that you probably have seen before in social studies class. And it'll say something like, 1 inch equals 100 miles on a map. And so really what a scale is just a ratio that compares two measures. So when you're trying to compare, 1 inch on the map and 100 miles in the real world, those are those two measures. And we're doing it as a ratio, that comparison there, because we want to always keep that relationship, that every time you have 1 inch on here, you have 100 miles in the real world. So scale drawing, you already saw an example of one. That would be like the map that we did. So it's going to be a representation of a real object that is proportional to the real object. So when we're talking proportional, that's where we're keeping it representing what it's like in real life. So not just dragging the side of my picture, but dragging the corner so that it keeps that same relationship. It's proportional to the real object. So with scale, there are two fancy words for bigger and smaller. If you have, like my picture that I was trying to make bigger, I was making an enlargement. It would be a larger image than the original. Or like in the zoo, you kind of have a reduction because you're making a smaller image than the original. With similar figures, sometimes in math, especially as we're trying to learn how the math goes, we won't necessarily do something that's big and giant like the big zoo taking it to the little map. We might just do something simple, like here's a triangle, let's make it bigger or smaller. And so when we do that, we have similar figures. They're figures that are proportional in size. So they're not the same size, but they are the same kind of shape. Not just that they're both triangles, but that their sides, their angles look right compared to each other. And when we end up doing the math, we're going to use something called scale factor. And so that's really kind of taking the scale and using it in a certain way to multiply to make this either bigger, enlarged, or smaller, reduce picture. And that's the idea.